In this lesson, we're going to learn about confidence intervals. We're going to use the normal distribution to solve problems that involve confidence intervals. Often it is impractical to survey an entire population. For example, if a light bulb company wants to test the number of hours that a light bulb will burn before failing, it cannot test every bulb. Propose a method that the company could use to determine the longevity of its light bulbs. We talked about this back in Math 9. They could use different sorts of samples. Maybe they pull off every 20th bulb that comes off the assembly, or every 50th bulb, or something like that. So they can't test the entire population, or they would never be selling light bulbs because they would be testing them all to burn out. Margin of error is the possible difference between the estimate of the value you're trying to determine, as determined from a random sample, and the true value for the population. The margin of error is generally expressed as a plus or minus percent, such as plus or minus 5%. And you'll hear about these in the news, especially when you're talking about elections. They'll say that these are accurate to certain degrees or certain percentage points, and they're often talking about margin of error. Confidence interval. This is the interval in which the true value you're trying to determine is estimated to lie, with a stated degree of probability. The confidence interval may be expressed using plus or minus notation, such as 54% plus or minus 3.5%, or ranging from 50.5 to 57.5%. So again, you will hear this in media reports, especially when talking about polling at election time. Confidence level. The likelihood that the result for the true population lies within the range of the confidence interval. Surveys and other studies usually use a confidence level of 95%, although 90 or 99% is sometimes used. So here's an example. A poll determined that 58% of people living in Canada know that the cost of living for the average Inuit is 50% higher than the cost of living for other Canadians. The results of this survey are considered accurate within plus or minus 3.1 percentage points, 19 times out of 20. So we want to state the confidence level. Now the confidence level is what percentage this would be deemed to be true. So we look at 19 times out of 20. This would actually occur. So what percentage is that? We go 19 divided by 20, and we get 95%. So the confidence level for this poll was 95%. Determine the confidence interval. Now the interval is the percentage of people that it's actually going to range between. Now they talk about 58%, accurate within plus or minus 3.1%. So the interval would be that range of data that fits this information. So 58 plus 3.1% is 61.1%, or 58 subtract 3.1, 54.9%. So the data, or the confidence interval, would be between 54.9% to 61.1%. So that is more likely where your range of people who would know that the cost of living for the average Inuit is 50% higher. More likely, this would be your range of people that would know this would fall within this range. So if the population of Canada was 33.5 million at the time of the survey, we want to state the range for the number of people who knew that the cost of living for Inuit is higher than for others. So what we do here is we use our confidence interval. Our low range was 54.9%. So we have 33.5 million people. We want to find 54.9% of that. So we need to change our percentage to decimal form, and we get 18.4 million. So if the true percentage was at the low end, then 18.4 million people would know this fact. If it was at the high end, we have 33.5 million people, and if we said that 61.1% of them actually knew this, we would have 20.5 million people. So therefore, somewhere between 18.4 million and 20.5 million actually know this fact. So somewhere in that range. So another example. To meet regulation standards, baseballs must have a mass from 142 grams to 149 grams. A manufacturing company has set its production equipment to create baseballs that have a mean mass of 145 grams. To ensure that the production equipment continues to operate as expected, the quality control engineer takes a random sample of baseballs each day and measures their mass to determine the mean mass. If the mean mass of the random sample is 144.7 to 145.3 grams, then the production equipment is running correctly. If the mean mass of the sample is outside the acceptable level, the production equipment is shut down and adjusted. The quality control engineer refers to the chart shown when conducting random sampling. So what is the confidence interval and the margin of error that the engineer is using for quality control tests? Well, our interval is what they are allowing the sample to be between. They are allowing it to be anywhere from 144.7 to 145.3. So that is our confidence interval, because that's the interval of measurements it is allowed to have. The margin of error. Well, what was the mean mass that they were aiming for? It was 145. So what we want to do is we want to find out what the interval is off of this 145. So we take 144.7, and we subtract the mean, and we get negative 0.3. We take 145.3, and we subtract the mean, and we get 0.3. So our margin of error is plus or minus 0.3. That's what gives us our interval. B, we want to interpret the table. Well, what this table is saying is that in order to be 99% sure, so 99 times out of 100 times, we actually hit the appropriate values. They need to make sure that they are choosing a sample of 110 baseballs. You need to make sure you pull off 110 baseballs to have a 99% confidence level that the machine is working properly. However, if we only want a 95% confidence level, we only need a sample size of 65 baseballs. And then if we want a confidence level of 90%, so if we want it to occur 90 times out of 100, we only need a sample size of 45. So what is the relationship between confidence level and sample size? For a constant margin of error, as the confidence level increases, the size of the sample also needs to increase. So it's important to note, we haven't changed our margin of error. Our margin of error is still plus or minus 0.3. What we are changing is our confidence levels. So to have a greater confidence, you need to use a larger sample. So just some key ideas. It is often impractical, if not impossible, to obtain data for a complete population. Instead, random samples of the population are taken, and the mean and standard deviation of the data are determined. This information is then used to make predictions about the population. When data approximates a normal distribution, a confidence interval indicates the range in which the mean of a sample of data would be expected to lie if other samples of the same size were taken, to a stated degree of accuracy. This confidence interval can then be used to estimate the range of the mean for the population. Sample size, confidence level, and population size determine the size of the confidence intervals for a given confidence level. A confidence interval is expressed as the survey or poll result plus or minus the margin of error. The margin of error increases as the confidence level increases with a constant sample size. The sample size that is needed also increases as the confidence level increases with a constant margin of error. So two different things there that you need to think about. The sample size affects the margin of error. A larger sample results in a smaller margin of error, assuming that the same confidence level is required. For example, a sample of 1,000 is considered to be accurate to within plus or minus 3.1% 19 times out of 20. Now notice, we're going to keep the 19 times out of 20, but we're going to change our sample size. So a sample of 2,000 is considered to be accurate to within plus or minus 2.2%. So the margin of error got smaller as we chose a larger sample size, but our confidence level stayed the same. And again, a sample of 3,000, so even a larger sample, the margin of error decreases again, but our confidence level stayed the same.